Welcome to the video. We're still discussing impulse and momentum. Now, we've already defined Newton's law in terms of momentum, which is that the net force is always going to be equivalent to the rate of change of momentum. Now, if we rearrange this equation by multiplying by change in time both sides, we'll get that the product of F net and change in time will give us change in momentum. Now, when we come to the issue or the concept of impulse, we are speaking about that left hand side of F net multiplied by change in time. That is what we call impulse. So now impulse can be defined as the change in momentum, or it can be defined as the product of the net force acting on an object and the time interval whereby this force acts. Now let's look at an example where we can apply this knowledge of momentum as the rate of change of momentum, as well as impulse as the change in momentum. So in example 5 below, we are asked to solve the question where a car of mass 500 kilograms is traveling with a constant velocity. That means that velocity is not changing, of 30 meters per second, when a driver realizes that she's exceeding the speed limit. So she decides to slow down. Now, she applies the brakes for 4 seconds. That is the time interval whereby she's applying brakes. And if a constant net force of 1,000 newtons slows down the car during that 4 seconds, determine the change in momentum in 4 seconds and the velocity of the car after 4 seconds. Now, to calculate the change in momentum in that 4 seconds is very easy, since we know that the net force is equivalent to the rate of change of momentum. Now, knowing that the net force is 1,000 newtons and the time interval is 4 seconds, we simply plug these things into the formula, and we use our calculators in order to find that the change in momentum is negative 1,000 newton second. Do not forget that the net force is a vector quantity. Thus, we need to check, is the force acting in the direction of the car, or is it acting in the opposite direction? So whenever you apply brakes, you are applying a force in the negative direction. Thus, it's negative 1,000 newtons, which yielded a negative change in momentum. So now going into question 2, we are asked to determine the velocity of the car after that 4 seconds. Well, momentum is simply the product of mass and velocity. We already have the mass of the car, and we already have the initial velocity. So knowing that the change in momentum is negative 4,000 newtons second, then we can use that information plus the mass of the car and the initial velocity in order to determine the final velocity. So the final velocity will simply be positive 22 meters per second. Do not forget that velocity, it is a vector quantity. Momentum is a vector quantity, meaning that the velocity value that we are going to get, it must have direction. The direction is positive 22 meters per second, meaning that it is still in the same direction the car was traveling. It is still continuing in the same direction, but now instead of 30 meters per second, it's moving at 22 meters per second.